Yeah, so I was wondering to do something fun in the weekend. So I'm a huge fan of steering behaviors. I think these are some of the awesome things you can do from scratch, right? But um, there's no, I have no recording about it. So I'm gonna make some steering behavior code and let's see how far we can go. But before that, I have something set up. These are basically the CMake for the build and the player GLB is the 3D model. Now, I've seen people do steering behavior in 2Ds, but I think it'd be awesome to do it in 3D. And because there's Raylib, animation loading has become significantly easier. Model loading, sorry, not animation. So let's see how far we go. Wait, I don't think I've set up the GTV, so let's do that. The usual suspects. Let's have main.cps. I think what I'm thinking is actually creating a simple. Actually, what I'm doing is we won't be painting anything. It's just to get me started. GB. I think yeah. Wait, what? Let's pay the homage. Basically the CMake. Wait, CMake is in there. Let's just use the CMake to build. Yeah, in the build. So basically, I want to do debug with GDC, not GDC GDB. So that's why this is component. What is that? Oh, need to a little bit of that should be CMake should be which is CMake shouldn't be on the build. CMake should be also. So now it makes sense. Yeah, we're building. Well, let's actually clarify one thing. It's basically very simple thing, right? We're just linking the libraries that we need. Really, I don't think we need GL, but I always kept it here. I always do keep it here. Yeah, this is very simple structure from scale. What else do we need? Wait, we have files. Okay, we need the JSON as well because my linter complaints. There. Let's actually create a getting long. We wanna click on build. Now let's just git at git ignore. Wait a minute, where did it? Oh man, it's not in the build. It should be there. Right. So basically. Actually, no, it's there. Damn it. So you can see I've already done this before. So initial commit, right, let's add all the things. yeah, we want to right now. Let's actually create a window. I don't want to call it window because I previously what I've done is I call it a window, but I don't think it's the right one. I can call it world. I think best thing is to call it a scene. Yeah, that's f not f scene dot h define scene dot h. Let's get our header that is done. So I'm gonna handle the window from the scene. Keep it as simple as possible. Also, what I'm gonna do is keep the constant in the different files. Because I used to do just save them on the scene or the window, but I don't think it makes sense because I need to pass it around. So what I'm gonna do is actually create this. Let's see. We need what? We need a window width. Window width. I think we need a window height. So we can call it. What else do we need? A string for the title. So include string yada yada yada. Constant std string, which is a title, and the title should be, I think it's string behavior. Oh, spelling is right. Yeah, that's the constants. So we need, I think let's just include Raylib here. Lib.h. Yeah, let's forget about that. I don't need constant here. I need the C. I'm gonna set it on a source file. Let's not set anything. Scene. I need a destructor for your scene. I think we should have it run. I actually, let me check. Have I put the render code in a different place or on the same structure? It is on the same, but we need an init. I'm going to use init in everything. I'm not going to set anything in a constructor because it gives me more control. So in the scene source file, let's scene source file, scene scene yeah, we need to scene and actually let's have a flag scene and let's set it to false by default. I think scene init false. Let's not do it. Let's do it here. I'm gonna init my Raylib window. Let's do the usual set complete. Don't think we need yeah, we need to close. So these are in the constants. We need that. So to initialize window, we need width. We need window height. We need the title. So title dot c string. Yeah, we have initialized, and we're gonna set the APS. Now we could have an APS on the FPS in the constant as well. Last time I did not do that, but okay, let's do it. FPS is 60. So let's just set FPS. What is this function called? Set target FPS to. You could use a namespace for this. Let's just make true, and now we have a scene initialized. So void scene run. First thing first, if scene is not initialized, right? stdcr initialize, how do you spell it? Scene first. I said this is not right. Let's just call it scene is not initialized. Right, and let's actually have an iStream. So scene is initialized. Now we will do the simple thing to run while window. These are all in the documentation, right? I'm not setting the basic one. Being in drawing spaces versus tab, right? Clear background black. We want pitch black, and I mean we don't have anything to draw right now, so let's just don't put anything here. Let's add the scene on my CMake. Just add the scene. Let's just build. Okay, we can't build though. First we need the scene in the source, but I think we should use one tree. Come on. Let's just use scene. I don't think we need iOSteam. Let's just call it scene dot. I think the more appropriate name should be scene start. Let's call it start, and here as well let's call it start. Okay, why are you complaining? Because we have no scene. Right, let's just see if it's okay. Okay, scene is not as nice, but yes, scene dot init. We have a window, so add basic window. Okay, next thing, before we draw anything 3D, we need to have a camera. Why are you complaining? For complaining, no. So let's actually have a camera. I'm gonna call it, if not this, M camera. The reason I'm calling it camera because Raylib also calls it camera. So I'm not gonna use namespace because I don't need it. Let's just call it M camera. Struct. Oh, I'm not gonna use struct here because I need it to be a singleton, right? So let's call class camera because I need the private features. Why am I calling it M camera? Right. So before we write, because it's gonna be a singleton, let's make this private. That's fine. Now that this is private, we can actually virtual M camera. We need a camera initializer. Okay, let's first set a static function to get M camera get instance, which will tell the camera instance that we have camera M instance. Let's just include M camera h. Why are you calling camera? Right. M camera. What I need to do is to set instance to now. This is a pointer. Okay, why are you complaining? Declare. Okay, it's not static. It should be static. It should. Right, let's start now. Let's just M camera. Let's just keep it version. We need a get instance. Let's just do that. M camera. Get instance if M instance is equal to now pointer instance equal to new and camera, and return the instance, right? So we have a singleton here. Now we need to have some basic stuff. We don't need this as private. Let's just go camera init. Let's just set it to false for now. Yeah, I am doing no. Camera. Let's call it this camera. Now it will give a write a function. So this will do my initialization. Okay, camera init. I'm gonna take a target. Let's just vector 3 target. Let's actually make it constant. This is my target to play. Target. Okay, so 20 minutes. Let's just set some defaults here. Oh, we need the camera as well. Camera, this is actually the main camera. So in the default state, we wanna do is set everything to 0. Let's do some explicit stuff directly. So camera, we need. Wait, I don't think we. This is not target, right? My mistake. This is position. So we can say camera, the position is the position, camera dot target, it is 0, so it's everything to 0 for now. Then camera field of view, this is a field of view Y, this is 45 degree because we're gonna do projection, right? For 3D we need camera perspective. Okay, the upwell of the camera, the y-axis should be 1, yeah. This is our up. Actually this is not 0.1, this is 1, and we need a projection. So camera projection is camera. Right, and finally we need is camera init true. So what I'm gonna do is in the scene we're gonna use camera, and in initialization we're gonna get the camera first. Camera get instance init position. For now this is gonna be vector 3 0.0 f 0.0 f. Actually I need this in bit up. I think the y-axis value needs to be higher. Right, I think I put 6 initially. No, a 6 is a bit too big. I'm gonna put 3. So we have a camera. Unfortunately we can't render anything yet. Let's just, because we need to draw something first, let's just get the camera here as well. Camera So you know what, let's just draw a grid for now. What are my defaults here? I have created a slice. I need actually slice is correct. And the spacing I could let me actually check. I have put 2. Okay, we need 2 because we are not looking to the target. Let's not actually, let's put the player first, that will make more sense. So include player, actually before I do that, let's put some paragraph. If player each define, yeah, wait, am I in the right track? Yeah, I think I am. So in the case of player, for now it's gonna render the 3D model. I think player constructor doesn't take anything. Virtual player, the init will take the position. Actually, select 3. Let's keep it in include Raylib.h. Let's use Raylib.h here. Next we need what? We need to render the freaking player. So we need a render function for this. So we have a render. Let me check what we need. Yeah, we need something to save the position. So we have a position. Then we need actual model, our 3D model. Right. So yes, actually in the scene, I'm gonna change it later. Let's actually have a bull is player init. I'm gonna have a source file that says player.cpp include player.h player. You know what, in the constructor we want to say that is player init false. We have not initialized the player. We need that virtual function, although I don't think we are doing anything. Although in the scene virtual function, need to close the window. There needs to be some bookkeeping in the void player init. We need constant vector of position. Let's actually player model path. This path should be in the, I'm gonna run it from build. This is structure, this path is for my whatever this is called, the way I have designed my code, the way I have structured my file system, right? So if you do it somewhere else, like in Windows, you might need to change this path. But for now, this will do. I think it's in the resources layer glb. Again, this will fail if I run from somewhere else. I need to specifically run, but I will fix it later, not now. It's not GBL, right? What am I saying? What is the extension called again? GLB. So GLB. These are player path, and what you're gonna do is let's just save the freaking position. We need to load the model. Actually, why title? I have no idea why this is small pieces. How do we do that? Yeah. Right. Here, model path. It's a C library, so we need to convert it to C string. Kudos to the actual maintainer, right? To have maintain this code in C. Oh, we don't need another parameter. Actually, we need constant. We have the model. We need to set. Okay, this is because the way the model was saved. So we need to rotate this model, transform. I think we need CMAT, not CMAT, sorry. We need the RayMath, right? RayMath. Model transform matrix rotate X, Y, Z. Yeah. So we need to transform this to vector 3. Then we'll do let's just make it more readable. For it should be degree to radian, so degree to radian into 90. Actually, you know what, this should be 0. It should be 0. Right, we have a basic rotation. So we need to actually set it to 90 degree on the x-axis, and we're good to go. We need to do the render though. Okay, well, yeah, one last thing we need to do is player init is equal to true, and void player render. Good check. Alright, is player init. This will actually make the thing very slow. Let's not check it here because if checks are expensive. Draw model. I mean, we won't notice it, but let's just do it. Again, this is the scale thing. Again, the way drum on. So in the CMake, player, in the scene, yeah, this has changed. It's not lowercase anymore, uppercase. So let's just initialize. We need the player here. So player, in this case, let's just write what we need. I'm gonna use a pointer. So let's for declare player. So these are I think we need to actually set the player to now pointer. What is going on? Yeah, and delete the player. Also need to close the window. That is one thing. Okay. So in the case of player, we need say new player. Actually, we don't need anything. We need player. In it, we need the position. Player position, I have played with it. I know the best value for this for the time being. Let's actually, what did I put? Yeah, player is these are actually not right. Oh no, yeah, it makes sense. What has happened is I want to put the player forward. So let's just 0 x-axis and y-axis, but to make it in front of the camera, we need to decrease the z value. So let's just do that, and then for the camera target, we have the camera. Where are you? Let's just camera and sense set. Actually, we don't have a target. Yeah, I think we're missing something. We needed something to look at. So what look at, which is a constant vector 3, and this is the target. So basically this is where we're going to look. Camera look at target. Yeah. Well, so what can I, this is actually target, is that it? It should be it. yeah, so we need something to look at. Here, player dot position. Yeah, so now we can actually draw player render. So player we are gonna render. Run this. Let's see if we can get any arrow. Yeah. Yes, we have a. The position isn't right. Is it 0.03? It should be 3. Alright, we have. We're totally in the up. So what is that? It's because I have done a stupid thing here as well. It should be 6. Yes, we are rendering the player. Let's just add one more thing. Show grid. What is called show grid? What it is actually called is draw grid. Sorry. Let's just draw a grid, and this should be 30 slides. Yeah. This basically how many cells, right? And we wanna have a spacing of 1.0. The distance between them, not distance, the size of each cell. Okay, we have a basic structure for now. What I need to do is actually build a state machine, because we want to add this animation, otherwise it becomes complicated. Let's actually point here. And one last thing we need to do, this for this video at least, is that in the scene we call it scene init. Let's just call it is scene init. Scene source file. Is scene init is false, and is scene init is true. Is scene init is true. Let's just run this. Go to build, make. Right. Change the name of what scene init flag. Yeah. Alright, this is it for now. I'm gonna go and create another video. And next video we're gonna go basically for the state machine. So we need a state machine to control the animation. So that's it for today. Thank you.